Good evening, everyone. Welcome to our value-added course, Data Analytics. I, Anas Habib Zubairi, Assistant Professor, Department of Computer Science and Engineering, will be taking you through the fascinating world of data analytics. This first module is called Introduction to Data Analytics. In this part, we will start from the basics, understanding what data analytics is, why it is important, and where it is applied in the real world. Now, before we dive in, let me ask you a simple question. Have you ever wondered how Amazon recommends products to you, or how Netflix suggests movies that match your taste? These are not coincidences. They are the result of powerful data analytics. And by the end of this module, you will begin to understand how these systems actually work. We will see now part 1, Overview of Data Analytics and its applications. In this module, we will learn about these topics: introduction to data analytics, types of data analytics process, tools and technologies, applications of data analytics, future trends and conclusion. What is data analytics? First of all, we have to understand that what is data analytics is. Imagine you are running a shop and you have a notebook where you write down daily sales. Those numbers on their own are just raw data. But if you analyze them, you may realize that sales are always higher on weekends. That insights helps you decide to keep more stock on weekends. That is the power of analytics. It transforms raw data into meaningful insights. If we say formally, data analytics is the process of examining raw data to discover meaningful patterns, valuable insights, and hidden trends. These findings help organizations and individuals make informed decisions rather than rely on guesswork or intuition. Now we see data versus information versus insights. Data, raw facts and figures, refers to unprocessed facts, numbers, or symbols collected from various sources. It can be qualitative, example colors, names, or quantitative, example numbers, measurements. Examples: a list of student marks 78, 85, 92, 67, 88. On its own, it does not explain performance or trends. Information, that is called processed data. When data is organized, structured, or presented in a way that adds context and meaning, it becomes information. Helps us understand what the data represents. Example: average marks of a class are 82%. This processed form of raw marks tells about the overall performance. Insights, actionable knowledge. Insights are deep understandings derived from information that guide decision making and actions, predictive and strategic in nature. Example: if class performance has been steadily improving by 5% each semester, teachers can adopt similar teaching methods for future sessions to maintain growth. So remember this ladder: data, information, insights, and decisions. Now, types of data: structured, that is databases, spreadsheets; semi-structured, XML, JSON; unstructured, text, video, and audio. In this picture, there are three figures: structured data, unstructured data, semi-structured data. You can see structured data figure. Some structure are seen in this figure. Unstructured data, there is no structure, there is no figure you will see. Semi-structured data, you will see some uh, figures that is made in semi-structured data. That is three types of data: structured, semi-structured, and unstructured. Structured data. Definition: structured data is highly organized and follows a predefined schema or format. It is typically stored in relational databases or tabular formats, where data is organized into draws, rows, and columns. Its characteristics are fixed schema. Data adheres to strict schema with defined data types, relationships, and constraints. Tabular format, organized into rows and columns, making it easy to query and analyze. Stored in relational databases, commonly stored in SQL databases like MySQL, PostgreSQL, or SQL Server. Easy to process, can be easily processed using SQL or other structured query tools. The examples of structured data are databases, tables in relational databases, example customer data, product catalogs, spreadsheets, Excel or Google Sheets files with rows and columns, CSV files, comma separated values by files with a clear structure. Use cases are financial records, example bank transactions, inventory management systems, customer relationship management system, that is called CRM systems. Challenges: requires a predefined schema which can be rigid and difficult to modify, not suitable for handling complex or hierarchical data. Now we see semi-structured data. The semi-structured data defines data does not follow a strict schema like structured data but still has some level of organizations. It often contains tags, markers, or metadata that helps define its structure. Its characteristics are flexible schema, no fixed schema, but it may have self-describing elements like tags or keys. Hierarchical or nested structured, often represented in formats like JSON, XML, or YAML. Stored in NoSQL databases, commonly stored in NoSQL databases like MongoDB, Cassandra, or Elasticsearch. Easier to scale, more flexible than structured data, making it easier to scale and adapt to changes. Semi-structured data examples are JSON files, JavaScript object notation files with key values pairs, XML files, extensions, markup language files with nested tags, log files, server or applications logs with varying fields. Use cases, web APIs, example data returned from RESTful services. Configuration files, example YML files for Kubernetes. IoT data streams, example sensor data with metadata. The challenges are requires parsing and processing to extract meaningful information, can be more complex to query compared to structured data. Unstructured data. The definition of unstructured data is unstructured data has no predefined structure or schema. It is often raw and unorganized, making it the most challenging type of data to process and analyze. Its characteristics are no schema, no fixed format or organization. Diverse formats can include text, images, videos, audios, and more. Stored in the data lakes, or file systems, often stored in data lakes. Example AWS S3, Azure Data Lake, or file systems. Requires advanced processing, needs need tools like natural languages processing (NLP), computer vision, or machine learning to extract insights. Unstructured data examples are text data, emails, social media posts, Word documents, multimedia, images, videos, audios, files. Sensor data, raw data from IoT devices without metadata. Use cases, sentiment analysis from social media posts, image recognition in healthcare, example X-rays, MRIs, speech to text conversation for voice assessments. The challenges are difficult to query and analyze due to the lack of structure, requires advanced tools and techniques for processing. Stored and processing can be resource intensive. Now we see why data analytics is important. Why data analytics is important in today's life? Let's think, can a company survive on guesswork alone? Probably not. Businesses, governments, and even individuals need data to guide their decisions. Here are four main reasons: decision making, efficiency, prediction, innovation. Now, what are they? Decision making is helps business, governments, and individuals take evidence based actions. Efficiency identifies areas for improvement, cost savings, and performance enhancement. Prediction forecast future trends using historical data. Innovation reveals opportunities for new products, services, or strategies. Now we have types of data analytics. There are four types of data analytics. These are descriptive, diagnostic, predictive, prescriptive. Descriptive means identify data, diagnostic means investigate data, predictive means predict future, descriptive means perform actions. Descriptive analytic. In this slide, we will learn about descriptive analytics. Descriptive analytics deals with past trends data. It basically finds out what has happened in the past, and based on past data or historical data, it predicts the future outcome. One of the main objectives of descriptive analytics is to look at the trends of past data, summarize it in an innovative way that can be useful for generating insight. Example, let's take an example of DMart. We can look at the product's history and find out which products have been sold more or which products have large demand by looking at the product sold trends. And based on their analysis, we can further make the decision of putting a stock of that item in large quantity for the coming year. Now we will see diagnostic analytics. Diagnostic analysis work hands in hand with descriptive analytics. As descriptive analytics find out what happened in the past, diagnostic analysis on the other hand finds out why did that happen, or what measures were taken at that time, or how frequent is it has happened. It basically gives a detailed explanation of a particular scenario by understanding behavior patterns. Now we can take the example DMART again. Now if we want to find out why a particular product has a lot of demand, it it is because of their brand or it is because of quality. All this information can easily be identified using diagnostic analytics. Now we see predictive analytics. Whatever information we have received from descriptive and diagnostic analytics, we can use that information to predict future data. It basically finds out what is likely to happen in the future. Now, when I say future data, does not mean we have become fortune tellers by looking at the past trends and behavioral patterns. We are forecasting that might happen in the future. Let's take an example. Amazon's recommender systems uses data analytics to suggest related items by analyzing customer purchase behavior and creating associations between products. Similarly, Netflix recommends movies and web series by studying viewing history, trends, and popular content. These personalized recommendations enhance user experience and boost customer engagement. Prescriptive analytics. That means what should be done. Prescriptive analytics helps to find which is the best option to make it happen or work. As predictive analytics forecast future data, prescriptive analytics, on the other hand, helps to make it happen whatever we have forecasted. Prescriptive analytics is the highest level of analytics that is used for choosing the best optimal solution by looking at descriptive, diagnostic, and predictive data. Now let's take an example of that. The best example would be Google self-driving car. By looking at the past trends and forecasted data, it identifies when to turn or when to slow down. Works much like a human driver. Now we will see data analytics process. In this, we will learn these six uh, topics: data collection, data cleaning and preparation, data exploration, analysis, modeling and interpretation, visualization and reporting, decision making and action. These are comes under data analytics process. Data analytics process. Data collection. Step 1 is data collection. This is the first step where raw data is gathered from various resources. Sources can include database, surveys, transaction logs, sensors, social media, IoT devices, or web platforms. The quality of data collected determines the effectiveness of analysis. The example is an e-commerce platform collects data on customer orders, browsing history, and product reviews. Data analytics process. Step 2, data cleaning and preparation. Raw data is often incomplete, inconsistent, or contains errors, so it needs to be cleaned. It needs to be cleaning. Tasks include removing duplicates data, filling missing values, correcting errors, and formatting data properly. Data preparation also involves transforming and structuring data so that it's ready for analysis. Example, removing duplicate customer IDs or handling missing entries in sales record. Step 3, data exploration and analysis. At this stage, analytics explores the data to understand patterns, relationships, and trends. Techniques include statistical analysis, visualization, correlation checks, and exploratory data analysis, that is called EDA. This helps identify potential problems or insights before building models. Examples, visualizing sales over months to detect seasonal trends. Step 4, modeling and interpretation. In this step, advanced techniques like machine learning, predictive modeling, or statistical models are applied. The goal is to predict future outcomes or uncover hidden patterns. Interpretation is key. Analytics translate technical results into meaningful business insights. Example of this is using a predictive model to forecast next quarter's sales based on the past trends. Data analytics process. Step 5th. That is step 5th. These, these all steps are under data analytics process. Visualization and reporting. Requests are Results are communicated using charts, graphs, dashboards, or reports. Tools like Tableau, Power BI, Excel, or Python visualization libraries help present data in a clear way. Good visualizations makes insights easier for makers to understand. Example, a dashboard showing customer churn rate, sales growth, and top performing products. Now, this is the patient experience analysis dashboard. Here you can see day of the week, department, date, patient's feedback, patient satisfaction, graph, patient count by department, patient feedback details, average average visit length by department, average wait time by department. This is the graph, this is the dashboard for analysis. Step 6, decision making and action. The final step is to apply insights in real world decision making. Businesses use results to optimize operations, improve customer service, or increase profits. It closes the loop as new actions generate fresh data for future analysis. Example, an online store offers personalized discounts to customers likely to stop purchasing, reducing churn. Now we will see applications of data analytics, business and marketing. Companies study customer behavior and run targeted campaigns. Example, Amazon recommending products. Customer behavior analysis targeted marketing campaigns, sales forecasting, market trend prediction. These are comes under business and marketing. Healthcare. Healthcare predicts diseases and personalized treatment. Example, predicting heart diseases risk. Patient data analysis for better treatment, disease outbreak prediction, personalized medicine, hospital resource optimization. Finance and banking, fraud detection, risk management, credit scoring, algorithmic trading. Example, credit card campaigns lack unusual spending patterns. Education sector, student performance analysis, personalized learning paths, dropout prediction, curriculum improvement. Example, universities use analytics to identify students needing extra help. Fifth, government and public policy, smart city planning, crime pattern analysis, disaster management, policy impact assessment. Example, analyzing traffic data to reduce congestion. Manufacturing and supply chain, predictive maintenance of machines, inventory management, demand forecasting, logistics optimization. The example is airlines predict engine failures using sensors data. Sports and entertainment, player performance analysis, game strategy development, audience engagement, content recommendations, e-commerce and retail, customer segmentation, prices optimization, inventory control, recommendation engines. The example of sports and entertainment is Netflix uses analytics to recommend shows to viewers. Example of e-commerce and retail is Flipkart analyzes browsing history to suggest products. Cybersecurity, threat detection, intrusion prevention, user behavior monitoring, fraud detection. The example is banks monitor login attempts to detect cyber attacks. Social media and web, sentiment analysis, trend detection, influencer marketing, ad performance tracking. Example, Twitter tracks trending hashtags using analytics. So these are 10 steps. These are the applications of data analytics. In which sector we are using the applications of data analytics. These are in front of you. Now future trends in data analytics. What are the future trends in data analytics? AI, nowadays AI plays an important role in every sectors, especially in IT. So the AI and automation, more analytics will be powered by artificial intelligence. AI and automation, agentic AI, augmented analytics, synthetic data, real-time and edge analytics, faster insights with IoT and 5G. That is streaming data. Ethics and privacy, explainable AI, federated learning, privacy first approaches. Data ecosystems, data fabric, composable architectures, data centric systems. Business value, data monetization, and executive AI literacy. So here we have learned and we have seen that overview of data analytics and applications of data analytics. What are the applications of data analytics we have seen in this previous slides, and what is the data analytics is, why it is important, what are the applications, where it is used. These are we have seen in the previous slides. Now in part 2, we will introduce to the analytical tools, that is overview of R. What is R? Python, Excel and Tableau. What are these tools? Now we in coming slides we will learn about these tools and we will see about these tools. Now here is the outline of the lecture. What are analytical tools? Importance of analytical tools in data analysis. Overview of R. Overview of Python. Overview of Excel. Overview of Tableau. Comparison of tools. Real world applications. Data sets for practices. And last is summary. Now what are the analytical tools? Now that we would understood that what data analytics is, the next question is what tools do we use to actually do all this? Thus, just like a carpenter needs tools to build furniture, a data analytics needs tools to analyze data. Analytical tools are specialized software or platforms that helps us collect, clean, process, and visualize data. These tools make it possible to extract insights efficiently. Formally speaking, in this definition, what are the analytical tools? Data analytical tools are a specialized platform and software applications that are designed to collect, process, and analyze data. They are an essential part of the data analytics toolkit, helping to extract meaningful insights from raw data and empower data-driven decision making. Key features of data analytical tools: comprehensive data integration provides a unified and accurate dataset for analysis and ensures insights are based on a complete picture. Data mining and exploration compatibilities enable teams to explore large datasets to discover patterns and relationships and to find new insights. Predictive analytics predictive analytics it uses patterns in historical data to forecast trends and outcomes, which aids in planning and decision making. Real time analytics business can develop insights based on the latest information, which helps them improve efficiency via faster decision making. Data visualization translates complex datasets into graphical representations such as charts, graphs, and dashboards to make the data accessible and understandable to stakeholders. Machine learning and AI. These compatibilities, these capabilities allow data analytics tools to automate complex analytical tasks while learning from data over time to improve accuracy and provide deeper insights. Data analytics use tools primarily used for data cleaning and preparation. Data analytics use specialist tools to help identify and fix errors within datasets, standardize data formats, and prepare data for analysis. Statistical analysis. performing calculations such as average, trends, and correlations to uncover patterns and insights. Data visualization, creating graphs, charts, and dashboards to make data easier to interpret and present. Prediction, predictive analytics, some data analyze tools use algorithms and models to forecast future outcomes based on its historical data. Now we will see importance of data analytics tools. Why do we need tools? Imagine trying to analyze millions of rows and data manually. It's nearly impossible. Analytical tools allow us to work faster, make fewer mistakes, and handle larger datasets. They also help in better decision, identify hidden trends, save time by automating tasks, improve accuracy, give competitive advantages. In short, without tools, analytics would be like trying to dig a mountain with a spoon. So, formally speaking, better decision making, provide data driven insights instead of relying on guesswork, identify trends and patterns, help organizations understand customer behavior, market changes, and performance metrics, efficiency and time saving, automate data cleaning, processing, and visualization, handle large data, manage, analyze, and visualize data sets that are too complex for manual methods. It also improved accuracy, reduced human error through statistical and automatic techniques, competitive advantages, enable business to make faster, smarter decisions ahead of competitors, supports research and innovation, useful in academia and R&D for testing hypotheses and exploring new ideas, communication and visualization, presents finding in clear visual formats, charts, dashboards for easy understandings. Now we will see what is R. Introduction to R. What is R? R is a language built for statistics and data visualization. It's a free open source and has thousands of packages for different tasks. It is very popular in research, healthcare, and academia. Sorry. R is the programming language and software environment that has become the first choice for statistical computing and data analysis. It developed in the early 1990s by Ross Ika and Robert Gentleman. R was built to simplify complex data manipulation and create clear, customizable visualizations. Over time, it has gained popularity among statisticians, data scientists, and researchers because of its compatibilities and vast era of packages available. The example of R is a researcher can analyze clinical trial data and create advanced charts to visualize patient outcomes. This is the example of R. Now we will see why to choose R only. Free, it is an free and open source. R is open to everyone, meaning users can modify, share, and distribute their work freely. Designed for data, R is built for data analysis, offering a comprehensive data set of tools for statistical computing and graphs. Large package repository. The Comprehensive R Archive Network (CRAN) offers thousands of add-ons packages for specialized tasks. Cross-platform compatibility. R can work on Windows, Mac, and Linux operating systems. Great for visualizations. With packages like ggplots2, R makes it easy to create informative, interactive charts and plots. Key features of R: cross-platform support. R works on multiple operating systems, making it versatile for different environments. Interactive development. R allows users to interactively experiment with data and see the results immediately. Data wrangling. Tools like Dippler and Tiddler help simplify data cleaning and transformation. Statistical mod- statistical modeling. R has built-in support for various statistical models like regression, time series analysis, and clustering. Reproducible research. With R Markdown, users can combine code, output, and narrative in one document, ensuring their analysis is reproducible. Example program in R. To understand how R works, here is a basic example where we calculate the mean and standard deviation of a dataset. We first create a vector data that contains numerical values. We use the mean function to calculate the mean of the dataset. The SD function calculates the standard deviation. These are the steps, and uh, we found the output of this. Mean is 27.5 and standard deviation is the number which you are seeing in the box. Now we see applications of R. Data science and machine learning. R is widely used for data analysis, statistical modeling, and machine learning tasks. Financial analysis use R for quantitative modeling and risk analysis. Healthcare. In clinical research, R helps analyze medical data and test hypotheses. Academia. Researchers and statisticians use R for data analysis and publishing reproducible research. Now we will see advantages of R programming. Comprehensive statistical tools. R includes many statistical functions and models, making it the ideal choice for data analysis. Customizable visualizations. R is visualization tools allows for customizations for a simple bar chart or a detailed heat map. Extensive community support. R has a large user base and there are countless resources, forums, and tutorials available. Highly extendable. The availability of over 15,000 R packages mean we can extend our functionality to suit any project or need. There's that now if we have some advantages of something, then we have a disadvantages of something also. So the disadvantages of R programming is memory intensive. R can be slow with very large datasets, consuming a lot of memory. Limited support for error handling. Unlike some other programming languages, R has less robust error handling features. Steeper learning curve. Beginners might face challenges with some of R's complex features and syntax. Performance. R performance can lag behind languages like Python or C++ when it comes to speed, especially for large scale operations. Now we will see what is Python. Nowadays, this language is very common and everybody knows it, especially the IT peoples. Now, what is Python? Python, on the other hand, is more general purpose and is extremely popular today because it's easy to learn and has a massive ecosystem of libraries. In analytics, Python is used for data cleaning, visualization, machine learning, big data. For example, Netflix uses Python for building recommendation systems that keep you hooked. Formally speaking, the definition of Python is it is one of the most popular and widely used programming languages nowadays because of its simplicity, extensive features, and support libraries. Python also has clean and simple syntax, which makes it beginner friendly, while it also provides powerful libraries and frameworks that make it perfect for developers. The definition of Python is a general purpose, dynamically typed, high level, compiled, interpreted, garbage collected, and purely object oriented programming language that supports procedure, object oriented, and functional programming. The history of Python is developed by Gaudio van Rossum in 1989 at Centrum Wiskunde and Informatica CWI, Netherlands. First released in 1991, Python 0.90 designed to emphasize code readability and simplicity. Inspired by ABC language but aimed to handle expectations and interfaces with the Amoeba OS. Python 2.0, released in 2000, introduced list comprehensions and garbage collection. Python 3.0, released in 2008, not backward compatible, major improvements in Unicode and libraries. Now one of the most popular languages for data science, AI, web development, and automation. There are some features of Python, which are they? We will see in this slide. Free and open source. Python is a free to download and use. Its source code is open for modification and sharing. Easy to code, simple syntax and beginner friendly. Easier to learn than C, Java or JavaScript. Easy to read, clean English like syntax. Uses indentation instead of brackets, semicolons. Object-oriented languages. Supports OOP, concepts, classes, objects, encapsulation, inheritance. GUI programming support. GUI apps help app can be built using Thinker, PyQt, Python, etc. High level language, no need to manage memory or system details. Large community support, active community forums and question and answer sites like Stack Overflow. Easy to debug, clear error messages, simple error tracing and correction. Portable language code runs on Windows, Linux, Mac OS without modification. These are the features of Python. Integrated languages works well with C, C++, Java and other languages. Interpreted languages executes code line by line, no separate com- completion step needed. Large standard library comes with built-in modules, math, triggers, date time, etc. Dynamically typed language. Variable types are decided at runtime. No need to declare data types explicitly. Front-end and back-end development. Front-end using PyScript in HTML. Back-end via Django, Flash, and other frameworks. Dynamic memory allocation. Memory is assigned automatically at runtime. No need to declare variable types manually. Core features, practical features, advanced features. These are the three features of Python. What are they? Core features include free and open source, easy to code, easy to read, object-oriented language, GUI programming support. Practical features, high level language, large community support, easy to debug, portable language, integrated language. Advanced features, interrupted language, interpreted language, large standard library, dynamically typed language, front-end and back-end development, dynamically memory allocation. These are the features of Python because Python nowadays are very common language and most of the IT students and IT sectors uses Python in coding. So Python is very important language. All the languages are important, but Python is simple and user friendly language. So that is why it is more important. And in IT sector, the Python uses are familiar nowadays. Now we will see Python example. अगर हमें hello world लिखना है Python में तो हम print bracket open inverted commas hello comma world semicolon ब्रैकेट को क्लोज हम बस इतना टाइप करेंगे पाइथन में और हमें मिल जाएगा हेलो वर्ल्ड इन वेरी सिंपल लैंग्वेज जस्ट टाइप hello world and we will get the answer. Example 2 variable and data types. If we type the name Adam, age 25, print name, print age, no need to declare types. Python figures it out. Python automatically it figures it out. So in output you will see the Adam and 25, the name of the person and age of the person. Directly you will see the output. Now the applications of Python in data analytics are data collection and cleaning. Libraries like Pandas and NumPy help in importing, cleaning, and preparing raw data. Data visualization. Tools such as Matplotlib, Seaborn, and Plotly create graphs, charts, and dashboards. Exploratory data analysis (EDA). Python makes it easy to identify patterns, correlations, and trends in data. Statistical analysis. Libraries like SciPy and stats models are used for hypothesis testing and probability analysis. Machine learning and predictive analysis. Frameworks like Scikit-learn, TensorFlow, and PyTorch are used for predictions and forecasting. Big data analytics, integration with PySpark and Hadoop for analyzing large scale datasets. Automation in analytics, automating repetitive tasks such as data entry, cleaning, and report generation. Business intelligence (BI), building dashboards and reports for decision making using Dash or Streamlit. Now there are some advantages of Python. The advantages of Python are easy to learn and simple language, simple syntax also, increases productivity with fewer lines of code, huge library support and community, cross-platform and portable, great for rapid development and prototyping. In earlier also I said that if there are some advantages of something, there are some disadvantages of also. So the disadvantages of Python are slower execution compared to compiled language example C++, high memory consumption, not ideal for mobile app development, limited in performance critical task, database access is weaker than in some other languages. So this is about Python. We have learned in the previous slides Python applications, what is the Python importance, advantages, disadvantages, its applications. These are the this is the Python. Now we will see Excel. What is Excel? Microsoft Excel is a powerful and widely used spreadsheet software that serves as a foundation tool for data analytics. Everybody knows that Excel. What is Excel? And many of the times we use Excel in daily day-to-day life. It allows user to organize, manipulate, and analyze data through a grid of rows and columns, which more specialized tools exist for large-scale data analysis. Excel remains essential for its accessibility, ease of use, and versatility in handling small to medium-sized datasets. There are some key features of Excel for a data analytics are formulas and functions. Excel offers a vast library of built-in functions like sum, average, VLOOKUP, and IF that allow you to perform calculations, look up values, and create logical statements. Pivot tables. A pivot tables is a powerful feature used to summarize, analyze, explore, and present summary data. It also used to quickly rearrange and slice data to identify trends, patterns, and insights without altering the original dataset. For instance, you could use a pivot table to see total sales by region or product category, charts and graph. Excel enables the creation of various types of charts and graphs. Example, bar charts, line graphs, scatter plots to visually represent data. Visualization is crucial for communicating findings effectively and making complex datasets easier to understand. Data sorting and filtering. You can easily sort data in ascending or descending order and filter it to show only the information that meets specific criteria. This helps in quickly locating and focusing on relevant data points. Power Query. This is an Excel hand-in that allows you to connect, to transfer and combine data from various sources. Power Query automates the data cleaning and preparation process, making your analysis more efficient and repeatable. What if analysis tools like Goal Seek and Scenario Manager help to explore different scenarios and predict outcomes. For example, you can use Goal Seek to find the input value needed to achieve a desired result. How Excel is used in data analytics. Data cleaning and preparation. Before analysis, the data must be clean and structured. Excel is used to remove duplicates, correct errors, handling missing values, and format data correctly. Exploratory data analysis (EDA). Analysts use Excel to get an initial understanding of the data. This involves calculating descriptive statistics, identifying outliers, and summarizing key variables using features like pivot tables. Basic statistical analysis. Excel can perform simple statistical tests and calculations such as mean, median, and standard deviation and correlation. While not a replacement for dedicated statistical software, it's suitable for initial statistical assessments. Reporting and dashboards. Excel is widely used to create static or dynamic reports and dashboards that present key metrics and insights to stakeholders. Small scale modeling. For simple forecasting or financial modeling, Excel's formula-based environment is an excellent tool for building and testing models. This is a graphs. This is some graphs in Excel that you are seeing in this picture. Sales for the month, sales for the bedrooms, sales by month, year, quarterly. These are the some summary sheet. These are the some summary sheet in the Excel, which you are seeing in this picture. Again, the advantages of Excel: easy to use and widely available. It is also a strong visualization tools, good for small to medium data sets, useful for quick analysis and reporting, supports add-ins for advanced analytics. Again, the disadvantages of Excel are limited handling for very large data sets, slower compared to dedicated analytics tools, higher chance of manual errors, limited automation compared to programming languages, not ideal for real-time analytics. These are the advantages and disadvantages of Excel. So this is all about Excel. In previous slides, we see that what is Excel, applications of Excel, what is important, why it is used, advantages in Excel, disadvantages in Excel, where it is used. These we have seen in the previous slides. Now we will see introduction to Tableau. What is Tableau? Tableau is a powerful tool used for data analysis and visualization. It allows the creation of amazing and interactive visualization and that too without coding. Tableau is a very famous as it can take its data and produce the required data visualization output in very short time. Basically, it can elevate your data into insights that can be used to drive your action in the future. Tableau products offering. What are the Tableau products offering? Tableau desktop, Tableau servers, Tableau online, Tableau Trader, Tableau Public. These are the products that Tableau are offering to us. Now, before we start Tableau, students, is there any doubt? Is there any questions that we have seen in the previous slide? If you have not understood in any topic, then you can raise your hand or you can ask. Is there any doubts? टैब्लू में, एक्सेल में, पावर बीआई में कोई डाउट है? अगर किसको कोई डाउट है तो वो पूछ सकता है. Now, why use Tableau? Tableau is the fastest and most powerful visualization tool. It is very easy to use. There are no complex formulas like Excel and other visualization tools. It provides the features like cleaning, organizing, and visualizing data. It's easier to create interactive visual analytics in the form of dashboards. These dashboards make it easier for non-technical analytics and end users to convert data into understandable ones. Now there are some features of Tableau. Tableau supports powerful data discovery and exploration that enables users to answer important questions in seconds. No prior programming knowledge is needed. Users without relevant experience can start immediately with creating visualizations using Tableau. It can connect to several data sources that other BI tools do not support. Tableau enables users to create reports by joining and blending different datasets. Tableau servers supports a centralized location to manage all published data sources within an organization. These are the features of Tableau. Visualization in Tableau. Bar chart. For the bar chart, we need 0 or more dimensions and 1 or more measures. To create a bar chart, simply select the desired dimension and measures and then select the bar chart on the Show Me section. Or drag the dimensions in a column and measures in a row. Pie chart. This is the bar chart. This is called the bar chart. And this is the pie chart. The circle one is the pie chart and the lines are the bar chart. For the pie chart, we need one or more dimensions and one or two measures. To create a pie chart, simply select the desired dimensions in measures and then select pie chart on the Show Me section. Stacked bar chart. For the stacked bar chart, we need one or more dimensions and one or more measures. To create a stacked bar chart, simply select the desired dimensions and measures and then select the stacked bar chart on the Show Me section. Side by side bar chart. For the side by side bar chart, we need one or more dimensions and one or more measures. To create a side by side bar chart, simply select the desired dimensions and measures and then select a side by side bar chart on the Show Me section. This is the side by side bar chart. Line chart. For the line chart, we need one date, 0 or more dimensions, and one or more measures. To create a line chart, simply select the desired dimensions and measures and then select the line chart on the Show Me section. Packed bubble charts. These are the packed bubble chart. These all charts are created and made in the Tableau, and it is very easy to made in the Tableau. For the packed bubble chart, we need one or more dimensions and one or two measures. To create a packed bubble chart, simply select the desired dimensions and measures and then select the packed bubble chart on the Show Me section. Here is the advantages of Tableau. Quick calculations. All the calculations on the Tableau done by the backend. So it is relatively faster than any other tool. Interactive dashboards. Tableau dashboards are very interactive and easy to draw. No manual calculation. All the calculations are done by the Tableau only. There is no manual calculation, but in some specific cases, we used calculated fields for calculation. A large amount of data. Tableau can handle a large amount of data. Different types of visualization can be created with a large amount of data without impacting the performance of the dashboards. There are disadvantages of Tableau. High cost. Tableau is a paid tool for visualization and it is a reason why people are not using Tableau so much. Static and single value parameters. Tableau's parameters are static and always single value can be selected using a parameter. Whenever the data gets changed, these parameters need to be updated manually every time. Limited data pre-processing. Tableau is a strictly a visualization tool. Tableau desktop allows you to do very basic pre-processing. These are the disadvantages of Tableau. Now we comparison of tools. Now what are the tools? We have seen the in previous slide R, Python, Excel, Tableau. These are the tools that we have seen in the previous slide. So the comparison of tools are Tool are Tool, Python, Excel, and Tableau. Stands strong in statistical analytics, tool data visualization, ggplot, rich packages for analytics, steeper learning curve, slower with very large data sets, academic research, statistical modeling, advanced analytics. These are the strength, limitations, and best use case. I think students you should write these comparison of tools, that is tool strength, limitation, and best use of this tool. R, Python, Excel, and Tableau. Please, students, you can write these uh, comparison of tools, and you can draw the table this. Done. Okay, 2 more minutes. These are the comparison of tools. Remember, these are the comparison of tools which we have learned in the previous slides. Tool that is R, Python, Excel, and Tableau. These are the comparison tools on the basis of strengths, limitations, and best use in case. Sorry. Okay, moving forward, the real world examples of analytical tools. What are the real world example of analytical tools? Number one, R, that we have uh, seen the previous slide. What is R, Python, Excel, and Tableau? Now we will see the real world example applications of analytical tools. R, statistical modeling in clinical trials, bioinformatics, social science research. R is used in these kind of fields. Python, machine learning, AI, fraud detection, recommendation systems, cloud and IoT analytics. Excel, financial analysis, budgeting, sales reporting, HR data tracking, small business analytics, Tableau, business intelligence dashboards, market analysis, customer insights, KPI monitoring, real time reporting. These are the real world applications of analytical tools in different sectors, in different fields. These are the data sets for practices. In this websites, you can use the data sets. Freely available data sets are there in this website. In Kaggle, UCI, Google Datasets Research, Search, World Bank Open Data, Government Open Data portals, GitHub, repositories. Uh, Students, please write these uh, datasets websites. You can practice previous all the previous tools, data analytical tools, and you can use the datasets using this websites. So please write down this website links. Website can directly access, and it is freely available. Data sets are there in these websites. In these websites are also freely available. So please, students, write these website names. इन वेबसाइट्स पे आपको बहुत सारे डेटा सेट्स मिल जाएंगे और जो रिसर्च की लाइन में आगे जाना चाहता है या जो रिसर्च करना चाहता है एमटेक वगैरह में जो प्रोजेक्ट्स बनाते हैं आप लोग या फाइनल ईयर में जो बीटेक फाइनल ईयर में जो आप प्रोजेक्ट्स बनाते हैं जो डेटा सेट पर काम करते हैं तो बहुत सारे फ्रीली अवेलेबल डेटा मिल जाएंगे इसमें जो डेटा सेट्स में काम आता है सॉरी तो इसमें आपको फ्रीली अवेलेबल डेटास मिल जाएंगे और प्रैक्टिस भी कर सकते हैं आप लोग ये वेबसाइट को ओपन करके और इट इज़ अवेलेबल ऑन द फ्रीली ऑन द गूगल। एक काम करते हैं आप लोग ये जो कोई भी दो वेबसाइट्स इसमें से आप कैगल की है या यूसीआई मशीन लर्निंग की कोई भी दो वेबसाइट आप ओपन करके देखो और उसमें आप सर्च करके देखो कि आपको तो कोई भी डेटा सेट मिल रहा है कि नहीं मिल रहा है। अपने गूगल पे जाइए, गूगल पे ये वेबसाइट का लिंक टाइप करिए और इसको ओपन करिए, उसमें देखिए कि आपको डेटा सेट मिल रहा है कि नहीं मिल रहा है। जस्ट फॉर प्रैक्टिस या अगर आपको मिल जा रहा है तो मुझे बताइए उसके बाद से। The common website is GitHub and Kaggle. I think most of the students are heard these names, GitHub and Kaggle. Have you found it? Okay, moving forward. The summary. Overview of data analytics. Data analytics is the systematic process of inspecting, cleaning, transforming, and modeling data. Its core purpose is to discover meaningful insights that directly support informed decision making and drive business growth. Applications of data analytics. This powerful discipline is leveraged across diverse industries to uncover hidden patterns, significantly improve customer experiences, optimize complex operations, accurately predict market trends, and enhance strategic planning for future endeavors. Introduction to analytical tools. The presentation covered essential tools are for statistical analysis, Python for versatile machine learning, Excel for accessible data organization, and Tableau for dynamic interactive data visualization. Together, these elements empower organizations and individuals to leverage data for smarter, more data driven decisions and sustainable success. So, students, today we began our journey in data analytics. We looked at what it means, why is it important, the different types of analytics, and the overview process. We also explored some real world applications across industries. In part 2, we got introduced to some of the key tools like R, Python, Excel, and Tableau, the very tools professionals use daily in analytics. I hope this gave you both the conceptual clarity and a sense of the practical tools you are encounter. What I want to take away from this is that data analytics is just not just a buzzword. It's the real world skill that touches every sector. Whether you work in business, healthcare, or technology, you will see these tools and concepts in action. Now, in our next session, we're going to go deeper into the foundations. We will talk about the different types of data, quantitative versus versus qualitative, and the formats in which data is stored and in exchange such as CSV, Excel, JSON, and SQL databases. After that, we will begin with the basics of data visualization, which is about presenting data in charts and graphs so that insights are easier to understand. This is the summary of the whole session that we have done today. Thank you all, and if you are any questions, please ask. These are the references in which you can get the information, in which you can get the data. So please write down these links. I think you should snap of it, click the snap of this references or some write down in your textbooks. Moving forward, any questions? Students, any questions from the previous slides, previous information? Please, you may ask. If there are any questions, if there are any doubts, you can ask the questions. Okay, thank you all for joining the session. Tomorrow, at the same time, we will meet again and discuss some other topics, some other sessions, some important session and very interesting sessions. Thank you all.